Good afternoon, everybody.
Good afternoon.
Afternoon.
Hi.
Afternoon, John.
It's John Daines here, and here we go. A talk about Leo, where it came from, how it happened, and where it ended. So we'll look at a bit about me. I started on 2.5 as an operator working for Bill Steel. I was on 2.5 from October 61 until February 64, and then I went to Minerva Road, initially to work for Bob Elmer while he was there, who ran the commissioning operators. And when he went, Alan Lyons took over, and I worked for Alan. And then when he went, I ran the team until the end of 1967, by which time it was System 4 and Minerva Road finished doing Leo work, and I went to Winsford, stayed with what became ICL until March 2002. What I want to talk about is really how Leo came about, what was the business background, what were some of the early wins, what lessons were learned, how it developed, and what was the legacy. If you saw the previous talk from Neville Lyons, who talked about the Lyons company, and even if you didn't, that ended up with the Lyons company being formed. There was a big company called Salmon and Gluckstein that was the largest tobacconists in the country, and they had a chain of tobacconists. They built cigars and sold them, and they wanted to get into catering, and they had, but I suppose it was brand consciousness in the 19th century. They didn't want to affect their brand, so they wanted someone to run the company with a different name. And there was a cousin called Joseph Lyons, and they set up J. Lyons to do catering. Initially, it started with exhibitions, and they ran enormous thousands of people at exhibitions and so on. But then they developed the tea shops, and so, some of us will remember tea shops that were there with their white fronts and the gold lettering, and the nippy waitresses. Something that Lyons was very keen on was quality, and all their people were well trained and well dressed. And they developed on to have corner houses, some of them very big, that could serve thousands of meals a day, and it was a big treat for people to be taken to a Lyons corner house. They continued to grow, and in Piccadilly Circus, or just by it, they built the Trocadero restaurant, which was the grandest restaurant in Europe when it was opened. It was that whole building, and it was decorated out inside with luxury and superb kitchens and food, and big banquets were held there. And then they moved on again into hotels. Many people will know of the Cumberland Hotel, which is just by Marble Arch on the junction of Oxford Street and Edgware Road. But the Strand Palace and Regent Palace hotels also belong to Lyons. And they did the catering for garden parties at the Palace and for Wimbledon. They started off catering for big exhibitions at Olympia, and then just down the road from Olympia, they took over an old piano factory, which became Cadbury Hall, and that grew and grew, and eventually the site was 13 acres. And then they expanded again out in Greenford, where they had an enormous tea factory and other stuff. You can see there were railway access next to it, and a canal, and the Great West Road. And that was another 30 acres. So a very large company. And they were, as well as doing the catering, they were making products. They made cakes, bread, Swiss rolls. They imported a vast amount of tea, ice cream, which they sold via grocery shops. So that was one sales channel, and they sold stuff through the tea shops. That meant having a large fleet of vehicles, and you can see some here in the center. And Lyons was a company that was vertically integrated. So they didn't just do the catering, but they also built their own vehicles. They would buy a chassis, and they had a company called Normand who built the superstructure on the vehicles to do exactly what they wanted. They had their own laundries because they had an enormous amount to do to clean the uniforms for the nippies and all the bedding and stuff for the in the hotels, building services, a large printing company. Obviously, they needed a lot of cartons for product, bigger boxes for shipping it and printing and so on. And it managed itself. And you can see by the size, by the start of the war, they got a large number of tea shops. They were selling millions of meals, but they were making very small profits. Could you mute people other than me, please?
I can only mute them all. You have to unmute yourself if you want me to do that.
Pardon?
I can only mute all.
That's all fine.
But if you mute all, then I can unmute myself.
Oh, yes, precisely so. It's gone off. I won't do it now, shall I? Or I'll do it anyway, because remove the noise. Okay.
Okay. So they had, can you hear me?
Yep.
Yeah. So
Yep.
they had masses and masses of transactions and an enormous administrative workload. But back in the 1920s, they'd recruited this chap, John Simmons, who was a top mathematician from Cambridge, and he set up what was called the Business Research Centre, and recruited a whole lot more people in to get the management under control. So this is long before computers were ever thought of, but their work on business processes and efficiency was they were great leaders at a national level, with their clerical functions centralized, stock management and so on. And they devised a system of management accounting. Instead of giving managers great piles of information, the idea was that each week they would report to managers, give managers information that they could make decisions on. They were early users of microfilm, for example, and he was a big leader in organization and methods in the country. And one of the people that he recruited just before the war was David Kaminer, who we'll hear a lot about. Now, after the war, Simmons had got wind of possibly that computers were about. So he sent two people to America, two of his people, T.R. Thompson and Standingford, to see what they could find about business management methods that might be of use to Lyons, and the use of computers. But what they found when they got there was that computers were being used for scientific and engineering and technical work, and a lot of it was secret, and people weren't particularly helpful. But they did meet a Professor Goldstein, who said to them, well, when you're back home, perhaps you could go to Cambridge University because Professor Hartree and Dr. Wilkes are planning or have started to build a computer called EDSAC. And while they were there, they used the time, because of course it was a lengthy transatlantic journey on a liner. While they were there and on the way back, they sketched out a lot of ideas for how one of these computers might be used for administrative work, because no one in America seemed to be interested in that. So that was that. They went in May, came back, and promptly visited Wilkes and Hartree at Cambridge, where they found that the machine was being built, but they were really having to scrabble around for money and to get equipment. There was a lot of valves and so on war surplus, but they could see what was being done and what was being planned. And Simmons came back, made a report to the Lyons board saying that once the people in Cambridge had completed the EDSAC, then Lyons should take over that that machine and that capability, and then develop it on to make a machine for them. So the recommendation to the board was that they should do this, and in October Lyons agreed that, and they offered Cambridge £3,000 to help them complete the machine. And Ernest Lennertz, who was an electrical engineer working for Lyons, was also seconded to Cambridge for a couple of years to help them put EDSAC together. And on November the 11th, Cambridge University agreed the deal. So if you think about that in business terms these days, and what a monumental decision that was, between May and November, they'd gone to see what could be done. They had the imagination and talked to Simmons and decided that they, as I heard a manager say once, took a punt on it. And they were away in an incredibly short time. Right. Now, if we go back a little bit before that, during the war, there was a need for a lot of factories to produce ammunition and shells and bombs for the war. And there were factories that actually made the explosives, but they needed a large number of other factories to produce bombs and shells. And the government didn't have the capability to run these, so they went to a lot of companies to get them to run factories. And Lyons was approached, and they ran a factory at a place called Elstow, which is just south of Bedford by the railway. And that was a factory that produced an enormous tonnage of bombs. And there is a thought that T.R. Thompson could have been involved with that, but there's no documentary evidence. But in any case, it was proof that Lyons were able to run businesses other than catering. And of course, they were doing their own vehicles and all the other stuff that they did. So while EDSAC was being progressed, Lyons, they had to plan and decide what to do. Now, there were a lot of changes that needed to be made. The EDSAC computer was a university computer that was about doing a lot of complex mathematics on fairly small amounts of data, whereas what Lyons needed to do was to do a lot of simple calculations on a large amount of data and do it reliably, day in and day out. So a lot of work had to be done. And during that period from 47 to 49, Lyons were planning. They recruited Dr. Pinkerton, John Pinkerton, who who was a Cambridge mathematician who'd worked on radar during the war, and who was known to the Cambridge people. And in 1949, EDSAC completed its first job, and at that point, Lyons knew that they could go ahead with Leo. But they had to do a whole lot of things. They were working in isolation. They were going to have to build it. They were going to have to program it. They'd need engineers and computer rooms and so on. But by 1951, they'd managed that, and 70 years ago, yes, 70 years ago, they ran the first business computer job in the world. And here are some pictures of Leo. An important thing here was that they needed to work in decimal and to deal with sterling, because that's what the financial system was in those days. So none of this had been done before for business. I'll come on to the other aspects a bit later on. But there were four things that needed to be done. As far as the hardware is concerned, as I said, a lot needed to be done for doing commercial data processing. Programming had never been done on such a scale and complexity. That people had written small programs in Cambridge, but these programs were a completely different order. Once the machine was running, it would require operations. It had to be used like any piece of machinery on a day-to-day basis and reliably to schedules, producing work to a known quality, and it needed to be maintained. So if we look at some of the what went on, some of on the hardware side, there was Pinkerton. Lennox had come back from Cambridge. Ray Shaw, who is in the picture on the top right there, sitting down. He's now, I have to correct that, I saw him on last week, and he's actually 97 now. And Ernest Kay was another engineer who's no longer with us, and Pinkerton and Lennox are dead as well. But the machine, as I said, wasn't just a copy of EDSAC. It had to handle the decimal and sterling, which I've mentioned. Importantly, it had to read in thousands of records. If you're doing a payroll for 30,000 people, that means you need 30,000 payroll records. You're going to have data on changes or this week's clock cards for those people that all needed to be input. And in terms of printing, a lot needed to be printed. And one of the things that immediately came up was the need for hardware buffers, because if you have to sit there and the processor has to wait while a card is read and then do calculations that wouldn't take very long, and then wait while it was being printed, then not much work would get done. So they developed buffers that would, the card reader would automatically feed a card into the buffer, which was a piece of memory, so that when it wanted to read a card, it would read it from the buffer, reducing the time. And similarly, if it was going to print a line, it would put it in a buffer, which was automatically emptied onto the line printer. I know we take this for granted now, but this was quite new, not something they would have needed at Cambridge. The memory was mercury delay lines, steel tubes full of mercury, 2048 short words, and on Leo 1, no magnetic tape or whatever. If you compare that with, in terms of bytes, it was about 4K bytes, it weighed half a ton. If you compare that with the 64 gigabytes in a telephone these days, you can see the change. They had to, because they were going to maintain the stuff, the equipment was designed for replaceable units. Big problem with reliability. There were thousands of thermionic valves which had to be tested. They did a lot of work producing test programs to test that the machine was working properly. If they found worse patterns, then they had to be catered for. And a lot of work on marginal voltage applications. In other words, reducing voltages to the point where perhaps it would fail. So if it was meant to run at, say, 10 volts, for example, they would have it so that it could run at 9 volts, and then they could run the test programs by reducing voltages and then weeding out the equipment that failed at that point. And of course, it all had to be documented. And all the way through this, they were learning lessons. It just hadn't been done before. Here are some pictures of, that's some of the tubes there. Top right, there's another one that's been saved and mounted. And on the right, you can see some of the exchangeable units. So they'd got handles, they could be plugged into racks. On the programming side, there was an initial team. It was led by David Kaminer, who almost invented systems analysis and set the standards for programming. Derek Hemme, who went to EMI, in fact. Leo Fantel, who went to South Africa. Tony Barnes, who ended up in charge of manufacturing before he left, and John Grover. There wasn't really, they didn't have analysts and programmers then. That they had to look at the problem, trying to understand it. What they weren't interested in was just automating what was there. They looked at what the task was and how a computer might help that. And to improve it by working more effectively. And we'll see some examples of some of the clever stuff a bit later on. They did a lot of work developing flow charting. So that's flow charting at a high level, dividing a job up into a suite of programs to see which programs did what and which files were passed between them, and then flow charting the individual programs themselves. They had to sort out the disciplines and standards and documentation for coding. It started off with purely machine code, but then that was developed to, it was still numeric, but they had a system for relative addressing so that every time coding was changed, all the addresses didn't have to be manually changed by the programmers, and a library of subroutines. But the scarce thing at the time was the computer. There was only one. So you couldn't do what a lot of people, including me, do these days, which is to write stuff and throw it at the machine and let it tell you when it was wrong. It was like gold dust machine time. So all programs had to be desk checked. So the design and the flow charts would be checked by a different person. And then if permission was that was passed, then coding would be done. And then that would be checked by a different person, going through checking the program against the flow charts, and preparing test data, making sure that there were data to cover all the cases that could arise. And then that had to be dry run through the program. And until all that was signed off, there wasn't a chance of being allowed onto the machine to do a trial. And here are some of the programmers. And Mary Blood, who's now Mary Coombs, is here today. A real world's first. And Frank Land, who's now 93, I think, is still here. Operations were important. Preparing the work, making sure that everything was there, that all the data that came in from customers, whether it was Lyons or after a while other customers, that it was punched up and that it was verified. So they had to develop the punching and verification methods. Job assembly, making sure that when a job was run, everything was there so that it came onto the machine with the main files and the input data, the correct stationery, instructions, and an important job. Logging activity on the machine. There were no typewriters or anything. There was a manual log where you'd write down the time, and the time was analysed afterwards to make sure that it hadn't been wasted or there hadn't been misoperations. Working with engineers when it broke, working with programmers when necessary, and meeting deadlines, whatever it took. And on the left there is Bill Steele as a young man. Now Bill's still alive and he's in his 90s, still living in Stevenage. And some people may recognise Dick Halford on the right there, who was at Hartree House when I first joined, but went to Casabonda. Maintenance, switching on and off the machine wasn't a trivial activity. On 2.5 when I started, it was switched off 4 times a year, just for the bank holidays, and getting it back working again was a hell of a problem. The engineers would be in really early, and if we got it back by mid-morning, everything had gone very well. Every day they would run test programs in the morning, marginal testing and valve testing. There were modifications to be made, particularly back in the early days with Leo 1. All the mechanical equipment had to be maintained, and then fault finding with electrical margins and what were known as mechanical margins, rulers or rubber hammers for tapping units and so on. Important to maintain records and making sure that anything that went wrong was fed back into the design team. Again, learning lessons. And there is Stan Evans, who's also in his 90s. He was on Leo 1 and he was at 2.5, I think, when I first went there, and then went on to Honeywell. So the whole thing was a team effort. Oops, come back. There was the customer himself who would sort out the requirements, and then the programming team would produce the programs. But all those groups, the engineers, the programmers, the maintenance team, and the operations people had to work with each other. Now, I'm talking about Lyons and Leo on the commercial side, but we shouldn't forget that elsewhere in the country, other things were going on. So up north, as people in London say, work was going on in Manchester. And in 1948, Manchester University had built a proof of concept machine. So the difference between that and EDSAC was that the intention always was that EDSAC would be a working computer to provide a service to the university. The Manchester machine was to prove the concept. It used valves. The memory was what was called a Williams tube, which was an oscilloscope, a cathode ray tube with a grid of wires over it that could read the dots off the screen. And it was very much used for my mathematical and scientific work again. And almost as soon as that was working, Ferranti became involved, and Manchester worked with Ferranti and the government. They had factories. By 1951, the Ferranti Mark I, which was a development of that machine, was installed in Manchester University. So roughly at the time that Leo ran its first job. But all this was at a much greater scale. You can see here that government paid a lot of money. 5 years for 35,000 a year is nearly £180,000. Lyons financed the whole thing themselves. And by 1952, they were selling machines, but the market driver was defence. And SIGINT, which is the sort of Bletchley Park type stuff. And here is a list of the machines by 1953 and 4. They were selling machines, but you can see here that they were either to universities or technical establishments. Although someone said Avros did do some payroll, but basically it was technical stuff. And it was part of a national program. I went to a thing about the baby at Manchester, and this list on the right was a document on the programming system for the Ferranti Mark I, and it just went to sort of almost anybody who was anybody in the country. Atomic Energy, Cranfield, Aeronautics, Defence, universities, Royal Naval College, and so on.
I understand that the modern day cost of each of those machines is the equivalent of £3 million. Sorry.
So if we just look at where we were between that time, there was the work that came out of Cambridge, which became Lyons, and that's when Leo started there in 1951, but Lyons didn't sell a machine until 1957 with a Leo 2, whereas Ferranti was selling machines from 1951 onwards. There was the National Physical Laboratory that was doing work, and they produced a machine called the ACE, which then, working with English Electric, became the Deuce. And there was a lot of work done by Birkbeck College, who worked with British tabulating machines, and Elliott's. And Lyons, of course. So back to the story. In 1952, a pilot payroll program was working, fully operational by 54. And then they went on to tea shops. And at this point, I'll show you a bit of film.
Clients, besides payroll, require their Leo to do several other routine clerical jobs. A job done every afternoon concerns deliveries to their 150 tea shops in London. There are hundreds of items of food, bakery goods of all kinds, kitchen goods in a wide variety, for the breakfast, lunch, tea and supper trade, and for take-home sales. All these, in a varying quantity each day, are delivered to a precise timetable to the tea shops. Understocking leads to lost sales, but with food, overstocking soon becomes intolerably wasteful. Each manageress has a standing order depending on the day of the week. After lunch each day, she considers her stock, weighs up local conditions, and decides what variations, up or down, she will make to her order. She speaks by telephone to head office, where her variations are taken down directly onto cards. There is no written record. What the girl hears, she punches. At the same time, a short paper tape puts in last-minute management decisions, such as occur with changes in the weather. Thus is flexibility provided. Again, the program is fed first, laying down the sequence for the multiplicity of calculations Leo will perform. Next, the standing orders and the telephoned revisions, T-shop by T-shop, are fed in, with the overriding variations on the paper tape. Immediately, packing notes begin to print out, 10 shops at a time. At the same time, charges to T-shops and sales statistics are being recorded. After further electronic processing, these cards provide the statistics for the use of the management. By means of discriminants built into the program, Leo will examine all statistics, but only print the ones that require action. Managers are, in this way, given precise, up-to-the-minute information, enabling decisions to be more closely related to trading conditions. The packing notes, which were printed by Leo 10 to a sheet, are separated, guillotined, clipped to a packer's board, and sent to the dispatch. Subtotals of the different items have been worked out for bulk movement to the several loading bays. Although the last revision is not telephoned until 3:30, by 4:30, Leo has printed for 150 T-shops and 40,000 items exactly what is wanted at each T-shop, in the right order for the different loading bays. They are also in the right order for the carman's calls, so that the goods at the front of the lorry can be delivered last, and the first call is just inside the doors. These are only a few examples of the wide range of work undertaken by Leo.
So what they're doing there on a machine with about 1,000 short words of memory is something that's really clever and complicated. It's effectively got online data entry. David Cameron has spent a long time looking at the daily orders from the T-shop manager S's and worked out that just about all of them had got a standard order that they needed every day. So what they did was to set up a standard order for each shop, and so the order only needed to be exceptions and changes. And then there were some overrides that the management could put in. So if it was going to be hot and sunny the next day, they'd supply extra ice cream. And if it was going to be cold and rainy, then they would supply stuff because they recognized that a lot more people would be going inside to get out of the rain and have some refreshment. So that's an example of typical Lyons management, reporting by exception and so on. And it wasn't long before they started doing bureau work for external customers. The word spread that this computer was about. And in fact, some of it was technical work. So they did work for the Ordnance Board on range tables. They did some work for de Havilland on missiles, I think. But the first Met Office computing was done on Leo, and the lady that did that developed the grid method that they still use effectively today. I mean, it's developed a lot, but they did the first work on Leo. They then went off and used Ferranti, and then I think they had a KDF-9. The weather forecasting people have always wanted the most powerful machine there is. And even though they've probably got the most powerful machine in the country, they'll want a more powerful one. They did the tax tables. There was a job for British Rail. At that time, you could take a parcel to any British Rail station, and there were over 5,000 of them, and have it sent to another one. So I had to work out the cost and the distances between any of the stations to establish the cost. And that was a job that took months and months. It was a restartable job, and they would run it overnight to fill in any spare time. when the machine was running 24 hours a day. And they started doing work for Ford, and they did the Ford payroll and many others. But it was filling up. They needed more, so in 1954 they came up with a suggestion for a Leo 2. They'd had the experience of using that. A lot of similarity, but there was a clever idea. They made the store 4 times faster by overlapping the words within the mercury, which meant that they could speed up the memory without making major changes to the processor. They had more registers and more sophisticated peripherals, magnetic tape. They tried in the early days to use magnetic tape on Leo 1 right back in the early 50s, and they had a contract with Standard Telephones, STC, but they never got it to work. But by this time, magnetic tape was available. Drums were available because other people were using drums, and this time they wanted to use alphabetic printers because the original Leo 1 was just numeric. And to do that, by 1954, the board said go ahead, and they set up a company called Leo Computers that would manufacture them. I need to get a move on. This allowed for much bigger programs because the program could be held on the drum and overlaid into the main store as required. Magnetic tape was used. These were the Decca decks that we had on 2.5 of fond memory. Samastronic printers, 300 lines a minute as opposed to about 100 lines a minute on Leo 1. And you could also print two types of stationery at the same time. Lots more standard software. There was the drum, there's a picture of it there. And a lot of work done again on reliability on restart facilities. All jobs were split into what were called restart groups, so that typically a long job would be split into, say, 20 groups, and every 1/20th it would punch out some summary information that would allow the job to be restarted from that point if there were a failure. There was selling machines to customers, so that meant setting up a maintenance and spares organization nationally, setting up operating standards. And here we have the Leo 2s. 2.5 was in Whiteley's here in Queensway, and there's a list down there of the various machines. From machine number 8 onwards, Standard Triumph, they had core store. So they were starting to move. The main processor was still valves, but the memory system was core store, driven by transistors, I think. And there were people there. Leo didn't have salesmen as such. They weren't saying buy a computer. They had people who were known as consultants. And here you've got John Ayres and Frank Land, who were 2 of them, who would go to companies and find what the real problem was and how Leo might help. But hey, as they say, this is all very blokey. Not many women there, are there? But there were masses of women involved with Leo, doing all sorts of jobs, from programmers, data prep, secretaries, engineers. And this is a list of some of the names, and here are some of the pictures. Some people are still with us. Oh, we got Gloria Guy here, who the colourful picture on the right. She was a data prep girl on Leo 1, and worked that long ago. Mary Coombs top left, there's Mavis Hines, who was the lady from the Met Office. Miss Hills, who provided a lot of the admin for the engineers in the early days when Leo 1 was coming on. The pilot is an engineer who was known as Synth when I heard her referred to. And then lots of people here. Bottom right, we've got the secretary of the society, Hilary Kavanagh, who's David's daughter. We've got authors. There's the PhD student who's doing a PhD and has spent the last few years writing a massive thesis about Leo. And then two of the key people at Cambridge on the project I mentioned, on the lottery project, are also females. So just some quick pictures. Bottom left there is who's here today on 2-1. Pat Ashcroft, yes. 2-5 is on bottom right there with Bob Stevenson at the keyboards, well, at the control desk. And that's where Frank Kelly, who's here today, worked. And I worked with Frank and Bob Stevenson. And 2-1, the Wills machine, British Oxygen that we used to use at night, Ilford Films at Ilford. But then Leo 3 came along, lots of new technology, transistors, core memory, and microprograms, which had been started at Cambridge. And Leo had, it was assembled, it might have been called perhaps a synthetic option in that all the ideas weren't invented by Leo, but what Leo did was put together things like microprogramming, the support for multi-programming, store protection, interrupts, device controllers that worked in a very clever way and that were virtually independent of the processor. The processor said, do that IO and don't let me know until you've finished, and whether you made a good job of it. Using microprograms, they could have special data handling instructions. It was a machine that could work directly in decimal and sterling. It was built for commercial work. And the tapes and printers were faster, but it had no tapes, drums or discs. And the picture there is of a microprogram from a standard Leo 3. So we can see on the left how things have changed, that the units that were plugged in on Leo 2 with valves became the blue handle printed circuit boards, that the racks there became as they are, that the delay line became core memory. That's a piece that's 4096 bits there. And at the bottom right, there's a magnified part of some magnetic cores with the 4 wires going through them. And it had software in quite a big way, an operating system that would permit multi-programming. It had the intercode language, which was quite a way above machine code, but was translated to machine code. And then high-level language, Clio came along, and the way they did that was to compile the Clio program into intercode, and then they'd already got a translator for that. And Richard Lloyd's here today, who I went on a Clio course, and Richard ran that. A lot of standard utilities, sort programs, either 3-tape or 4-tape sorts, both clever, standard print routines and so on. It was all done as a team effort, and the hardware and software were designed together. A lot of the hardware that Pinkerton and his team were designing had facilities in it so that the master routine people with John Gosden said, we need some hardware to do that, and the whole thing worked together. And again, we've got a lot of machines that were sold to a lot of the big blue chip companies. There's a list of those at the top. Some of them had been customers on Leo 2 on the bureau. CAV was done on Leo. Durlackers bought their own machine. Quite a lot to the public sector, customs and excise. We've got someone here from Southend, Board of Trade at Eastcote for trade statistics. 4 of the dockyards, 2 groups of London boroughs, one of which had done a lot of work on Leo 2, Manchester and Coventry corporations, and the gas board. And overseas, rightly or wrongly, the first machine delivered after 3-1 was sent to South Africa, and Tony Morgan went out to commission that. And then other machines, there's another machine in South Africa, and then a group of machines in Australia. And then they looked at selling them into Europe, and the country picked was Czechoslovakia. Some of the people like Frank Land and his twin brother here, Ralph, had spoken German. Dan Broido, who'd worked on Lecter, also spoke German and Russian and East European languages. And we sold 3 machines in Czechoslovakia. And another quick bit of film. This is the Durlackers Leo 3, and it's a film that some of the operators obviously made, presumably with an 8mm camera. Bill, Mike and Brian, 3:45. Looks like someone working offline. Mag tape libraries. Ampex TM4 tape decks. The tapes were attached with couplings. Elliott paper tape readers, 1,000 per second. And the operating was done through a bank of keys. So the output to the operator was on an IBM typewriter, not a golf ball, but a typewriter with traditional method. Could either print in black or red, but the input was through the keys. Rows of printed circuit boards. An overexposed picture of a printed circuit board. Some of the back wiring. And the engineer's control panel. Analects printer, 600 lines per minute. Right. Yes, I've showed that. Those people who worked on Leo 3, it may bring back memories, but not everybody here would have perhaps seen a Leo 3 in operation. So that's in there. So what were some of the systems? I suppose the really big one was telephone billing. Every phone bill in the country was produced on a Leo from about 1967 until 1980. The Clio language was used by many customers. It took longer to compile, but it was quicker to write and more accurate. What were some of the other things? There was the online document reading. The offline reader was the lector, but there was an auto lector device that would read documents at high speed. Lyons used this, and they used it in conjunction with a Xeronic printer. So they would read forms that the roundsman filled in on the auto lector, and then after the job was finished, they'd produce a magnetic tape that was then printed offline on the Xeronic printer to produce the new form. So it was a sort of closed loop paperwork system, and they didn't have to do data prep. And they had offline Kimball tag readers, which were an early form of retail point of sale information. Data transmission. The post office, at one time, all postal orders went back to Chesterfield and were then, they were read by some readers made by Crossfield. The Crossfield readers in Chesterfield were linked onto one of the post office machines in Charles House. So they were reading stuff at speed over dedicated lines. A very large training school. We've got people here from training, teaching programmers and systems people and engineers, big configurations, lots of maintenance facilities. They'd learned from the early machines, and Leo 3 had superb facilities for the engineers. In fact, it proved to be extremely reliable, so not necessarily used very often. And here are some pictures. There's the lector, and Dan Broido, who was the main engineer, a Kimball tag. Some of the people on 3.1 probably still have nightmares about those. And here are some pictures of machines. 3.1 at the top. The bottom right hand corner, there's Manchester Corporation, and you can see here that they're sort of gargoyles. This was in the basement of the Victorian Town Hall, so there were marble pillars and gargoyles, and they were visited once by Commander Grace Hopper, the American naval lady who did so much with COBOL. Some of the big post office machines. On the bottom left there was this amazing card reader that the post office had, made by the Uptime company, and it would read 2,000 cards a minute, and it would pocket select. So they'd come down the left hand side, and before it got to the center, it would be read into the machine, and the machine would decide whether to pull a gate across to put the card into the center to say that it had been accepted as a good card. And any cards that were either faulty or they didn't select in time would go into the far side. Absolutely amazing. And you can see on the left a typical trolley when they were doing telephone billing, that they would wheel these trolleys of cards in for a telephone area, and where the cards came from. This was before subscriber trunk dialing. If you made a long distance call, you had to ask the operator for the number, and for every call they would mark a card with where it had come from and where it was going, and then these were subsequently used for billing. After Leo 3, the company produced System 4 and moved in a different direction, but recognizing that customers had a large investment, the company did some work to preserve that. So on System 4, there was a Clio compiler that was known as the Clio Bridge, and I think people like Manchester and Coventry probably used that, and other users, so that the programs could be still run until they were rewritten in COBOL, or perhaps not rewritten at all. And then even later, getting towards the end of the 1970s, the post office were having delays to getting the whole of telephone billing moved off the Leo machines. And the company had produced some 2960 systems called DME, which they'd produced for System 4 and for 1900. And Tony Morgan worked with the people in Scotland to produce a DME machine that would run the Leo code. It was a microprogram machine, so the Dalkeith Centre took the Leo microprograms and put them into a 2960, and that would then use 2900 peripherals, but would run the Leo programs. So if we look at what came out of it, some of the first developments, it was all business driven and came really from Simmons and the work that he'd done and driving what was done on Leo. Using what could have been seen as very primitive technology, making it into working systems, and very visionary people pushing the boundaries. And as it says, big payrolls, and the payrolls never failed. I mean, Leo 1 was unbelievable in a way, right until the end. It just kept running, and when you think of all the standby arrangements that started to come along on Leo 2 and Leo 3, where people could go somewhere else if their machine broke. If Leo 1 broke, it was broken. Things like the T-shops, online development, online data collection, direct input from paper, microprogramming, all these things all put together. And the GPO, who looked very carefully at what machines they should use for telephone billing, decided that the only way they could do it was to go for Leo, and it was a massive success. So what have we got left? We've got some memories, and it was really about the people, the management that was there, that recruited good people, not all necessarily graduates. There was an aptitude test, and if people could do the aptitude test, then that gave an indication that they might be the sort of people that Leo would wanted. it was about getting it right. It was about teamwork. Good place to work. And then a lot of the people that came from Leo went on. You've got people like Peter Herman, who went from Leo and then went to Dunlop and ended up on the main board of BOAC, having produced the Boadicea reservation system. Frank Land, first information systems professor in the UK, now an OBE, and a whole lot of others, John Ayres, John Godsman, Ralph Land, who got a CBE for all the work that was done in Eastern Europe, and David Kaminer, who really, when it started, did so much to set the standards and for the way that systems and programs should be done. And his final job for ICL before he left was managing the project in Brussels for the EEC, for which he again got an OBE. So a good idea, clever people, and using stuff that if you talk to young people today, they've got no concept of what went on and the sort of equipment there was. But today, computers in business, we couldn't survive without them. People have got computers in their pockets that are way more powerful than anything we ever had. And what's being done, preserving the legacy. David Holsworth from the Computer Conservation Society had done a lot of work on KDF9 in almost software archaeology, he regards it, I think. And he took on Leo having no knowledge of it at all. And from that has produced an emulator, and from some listings that we found for the translator and the master routine, we can now run the master routine and translator and translate into code programs, and that's available if people want it. And finally, the Leo Computer Society that started off as really just a reunion group in the rugby club in London, with people like Frank Kelly and other people, has now become the Leo Computer Society, which is a charity. And that society has worked with the National Lottery, and a joint bid was put in to the National Lottery Heritage Fund saying, look, what went on in Leo was a really significant thing in the national history, and deserves to be preserved and known about. So as a part of that, we had a phase 1 and then a successful phase 2 bid for a project that will span 4 years and will attract £370,000 of lottery money, which has enabled a lot of documents to be scanned. There's a new website. There's a virtual reality recreation of Leo 1 being made. Now, they have found 104 photographs that were, I think it was 104, possibly 106 now, photographs that were taken within that room in Cadby Hall where Leo was. And that's enabled at different times, but that has enabled people to make an accurate model, a digital model of the room and the equipment, and the pilot of that is quite remarkable, and it will be used as something that you can walk around, but it will be used as a way into the vast amount of information that's held in the websites, so that if you go in and touch a piece of equipment, it'll tell you some information, and then it'll give you more photographs and details. And the idea is that it will run on things like iPads. So it not necessarily something where you'll need a virtual reality headset, because this is something that needs to go into schools. Cheerio, Frank. Nice to see you. And a new film is being made. Now, there are various films, but this is being made by a professional group. And the aim of this is to be a film that can be used in schools and generally, and something that young people will understand, but it's also intended that it will be a film of some of the people who are still with us from the early days. We're nearly there. There are books that have been written. The one on the left that looks all white, David Cameron, John Harris, Frank Land and Peter Herman and other people put together this book called User-Driven Innovation. And that's what it was. It started with users knowing what they wanted and building some equipment to do the job. It didn't start with people producing equipment and selling it. The first book was in the center. Peter Bird, who was ended up as manager of computing at Lyons, put together that book, which is, I think, still available. The book on the top right, Georgina Ferry, who is a famous journalist on the technical side, produced that book. There's the book that Simmons produced called Leo and the Managers, which is very scarce. And in the bottom right, a small book called Leo Remembered, which was put together by members of the society and was really people who'd worked on Leo and some of their remembrances. And there's another one of those hopefully on the way. So hopefully I've gone through what I intended to do.
John,
yes,
Leo Remembered, edited very well by Hilary, of course. Hilary Kaminer.
Yes, it was edited by Hilary Kaminer, who's putting together the next one. And as you can see, we have a Guinness World Book of Records. So here we've got some of the people. We've got there is this memorial that's just near Olympia that was unveiled by Steve Shirley and Frank Land. There's David Kaminer and his daughter Hilary, who's still with us. And if we look at what was on the left there, that doesn't fit into anyone's back pocket. And if we look at the sort of developments that have come on in the middle, you can see that with a 64 gigabyte chip, we're looking at something that would have been 8 million tons worth of mercury and goodness knows how much money. And after I put this together, I discovered that they're actually 1 terabyte SD cards. So, I mean, that is just scary. But there's something that does fit in your back pocket that's a commercial computer, effectively, that does things that people like David Kaminer and Simmons would probably never have even imagined. Thank you.